Starting in D001 mode, I simultaneously press increment and decrement. The first digit blinks. I increment or decrement to B, then press enter. The second digit blinks. I increment or decrement to 0, then press enter. The third digit blinks. I increment or decrement to 8, then press enter. The fourth and final digit blinks. I increment or decrement to 4, then press enter. Once the display stops blinking, I'm in parameter B084. I press mode again to read the current entry. Note the drive is currently in state 00, and the program LED is lit, indicating that I can change this entry. If you want to both clear any previous errors and initialize this drive to the factory default, I increment this parameter to 02. Since clearing errors and returning the drive to factory defaults is kind of a momentous occasion not to be undertaken lightly, the means of doing so is a little bit more complicated than entering other entries. Believe me, this procedure takes practice, and the moment you get good at it, you're gonna forget it. Luckily enough, it's in the manual. Listen to the whole procedure first before attempting it, since several things must happen in a specific sequence. To reset this drive to factory defaults and clear it, one needs to press and hold both mode and decrement keys. Then one presses stop reset. The display kind of wigs out. Release stop reset first, then release the simultaneously held mode and decrement keys. If you've been successful in resetting and clearing the drive, you'll be returned to the initial default D001 parameter. Now we need to program this drive to recognize what type of motor we'll be driving. One does so by entering the motor nameplate into the motor drive using the motor parameters preceded by an H, notably H003, motor capacity selection, and H004, motor pole number selection. For this example, I'm making use of a 3-phase AC squirrel cage induction motor with a 1/4 horsepower output, roughly 200 watts. The motor has a nominal speed of 1725, which corresponds to a synchronous speed of 1800 RPM. This means the motor has 2 pole pairs per phase, or 4 poles per phase. Navigating to the parameter H003, motor capacity, we find the entry at the factory default of 0.4 kilowatts, or 400 watts. One decrements to 0.2 kilowatts, or 200 watts, and presses enter to save this value. Navigating to parameter H004, motor pole number selection, we find the entry at the factory default 4. This matches our given motor, so no change is warranted. Alright, here's your next challenge. Given a motor with the following nameplate data, determine the entries for H003 motor capacity and H004 motor pole number selection. For basic direct operation with our initial example motor, we've performed the steps necessary to program this motor drive. There are a number of other factory default settings that I've purposely skipped, particularly maximum frequency and acceleration and deceleration times and patterns. We'll examine these parameters in later lectures. We'll operate this motor with parameter D001, the output frequency monitor, being displayed. To directly operate this motor, an operator would position the frequency adjustment knob all the way counterclockwise, corresponding to minimum excitation frequency, and pressing run. Note the run LED indicates the motor is in operation, but it's not moving. As an operator repositions the frequency adjustment knob clockwise, the motor drive increases applied frequency. The motor accelerates and speed stabilizes. When an operator pegs the frequency adjustment knob all the way clockwise, corresponding to the default maximum frequency of 60 Hz, the motor accelerates to an excitation frequency of 60 Hz and then stabilizes. When an operator dials the frequency adjustment knob halfway, the motor decelerates to this new speed and stabilizes. When an operator presses stop, the motor decelerates and turns off. Note the run LED turns off after the controlled deceleration period has ended. When an operator presses run when the frequency adjustment knob is halfway, the motor drive increases the applied frequency to roughly 30-ish Hz. The motor accelerates and speed stabilizes. When an operator presses stop, the motor decelerates and turns off. Note the run LED turns off after the controlled deceleration period is ended. When the operator presses run when the frequency adjustment knob is pegged fully clockwise, the motor drive increases applied frequency to 60 Hz. The motor accelerates and speed stabilizes. When an operator presses stop, the motor decelerates and turns off. Note the run LED turns off after the controlled deceleration period has ended. While the motor drive is running, one can navigate and display various operational parameters. We'll initiate operation with parameter D001, the output frequency monitor being displayed. As previously, the motor accelerates and eventually speed stabilizes. While in operation, when we navigate to parameter D002, output current monitor, we find the unloaded motor is drawing roughly 1.2 amps. Alright, here's your next challenge. Use the parameter list in the user's manual to interpret the data displayed when I navigate to parameter D013. The motor drive at 60 Hz and the motor stabilized at the no load speed. The motor drive is saying 209. What does the data in parameter D013 mean? As a further challenge, consider the following behavior. When I press stop, the motor drive reduces excitation frequency. Note that the data in parameter D013 also decreases as the motor decelerates and comes to a rest. Similarly, when I press run and the motor drive increases excitation frequency during the acceleration period, note that the data in parameter D013 also increases as the motor accelerates and stabilizes at full speed. What does this behavior have to say about the data in parameter D013 and the excitation frequency during acceleration and deceleration periods? For the curious, another whole lecture on this behavior awaits. Until then, this concludes the installation and initial programming of an Omron 3G3JX-AE004 motor drive for basic direct manual operation. We learned to install the drive, interpret the status of the drive using both indicator LEDs and the data display during operation and programming, navigate to specific parameters, change parameters, reset the drive to factory defaults and clear errors, enter motor capacity and pole number selection data, and directly operate the drive. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.